Please follow along on your handout as we work this problem together. A man uses a large ramp to lift a box onto the roof of the school. The box has a mass of 150 kilograms. The ramp is positioned at 25-degree angle from the horizontal. The man walks with a constant velocity, pushing the box with a force of 800 newtons. Number 1. Draw a qualitative force diagram for the box. Please pause the video now and try number 1. When you are done, please press play and check your answer. The force of gravity pulls down on the box. A normal force pushes up on the box from the ramp. Because the ramp is at an angle, the normal force is at an angle. The normal force is straight, perpendicular up from the ramp. An applied force is caused by the man pushing the box up the ramp, and a frictional force in the direction of down the ramp opposes the motion of the box. Let's look at our force diagram in a little more detail. The gravitational force pulls straight down. This force acts only in the y direction. Every other force is at an angle. Therefore, the frictional force, the normal force, and the applied force all have both horizontal and vertical components. That makes this problem a little challenging. Using the methods we've done so far, we would have to find x and y components for all three of these forces. While we know how to do this, this is a lot of extra work. We can kind of take a shortcut here. What we're going to do is we're going to rotate our diagram. We're going to make this our x-axis and this our y-axis. Now we have three forces that are right along the axis. The applied force acts only in the x direction. The normal force acts only in the y direction, and the frictional force acts only in the x direction. The only force at an angle is now our gravitational force. We just made this problem a lot easier by rotating the axes. Let's return to our drawing, our original drawing, and redraw it with rotated axes. Frictional force to the left, applied force to the right, normal force up, and a gravitational force at an angle. Number 2, create a force table. Use a protractor, a ruler, and graph paper to A. Determine the forces that act in the x direction and the y direction. B. Determine the normal force in the x direction and the y direction. C. Determine the resultant value of the normal force. As always, let's begin by listing our forces. We have a gravitational force, a normal force, a frictional force, and an applied force acting on our box. As always, it does not matter what order we use these forces in, but let's start with the gravitational force. Gravitational force equals mass times acceleration due to gravity, which in this case is 150 kilograms times 9.8 meters per second squared. The gravitational force is 1,470 newtons. Because this force acts at an angle, the gravitational force has both an x and a y component. Let's begin by calculating those now. We'll start by drawing a vector to represent our gravitational force. Let's use a scale of 150 newtons equals 1 centimeter. Using this conversion, we'll multiply 1,470 newtons times 1 centimeter over 150 newtons. And we'll obtain a length for our gravitational vector of 9.8 centimeters. The gravitational force acts at a 25-degree angle. Let's begin by drawing this vector now. I'm going to start by drawing a 25-degree angle from the vertical. I know that my gravitational vector should be 9.8 centimeters long at this scale. This is my gravitational force. My gravitational force has both a vertical and a horizontal component. Let's begin by calculating those now. Let's begin with the vertical component. The vertical component of my gravitational vector measures 8.9 centimeters. Using my conversion factor, that 150 newtons equals 1 centimeter, the length of my gravitational vector in my y direction is 1,335 newtons. Because it acts in the downward direction, the vertical component is negative. The vertical component of my gravitational vector is negative 1,335 newtons. Let's measure our horizontal component. The horizontal component measures 4.1 centimeters. Using my conversion factor of 150 newtons per 1 centimeter, I can determine that the length of my gravitational vector in the horizontal direction is 615 newtons. Because it acts to the left, my horizontal component is also negative. The x component of my gravitational vector is negative 615 newtons. Now let's add our applied force. Our applied force acts directly in the x direction. The applied force is 800 newtons. (800 newtons) times my conversion factor of 1 centimeter per 150 newtons, the length of my vector for my applied force should be 5.3 centimeters in the horizontal direction. I'm going to begin where I left off with my gravitational vector and draw my applied force vector in the x direction at a length of 5.3 centimeters. This is my applied force. The applied force in the x direction is 800 newtons. Because the applied force acts only in the horizontal or x direction, the y or vertical component is 0 newtons. The box moves at a constant velocity. Therefore, the forces are balanced. As a result, I know that the total force in my x direction is 0 newtons. In addition, the total force in my y direction is 0 newtons. Because the total force is 0, I know that my force vectors must end at the same place they started. I have two forces that are not accounted for. The normal force, which acts in the y direction, and the frictional force, which acts in the x direction. I can use these vectors to determine the magnitude of my forces. Let's begin with the normal force. The normal force measures 8.9 centimeters. Using my conversion of 150 newtons per 1 centimeter, my normal force is calculated to be 1,335 newtons. Because it acts in the upward direction, my normal force is positive. The y component of my normal force is 1,335 newtons. Because it only acts in the vertical direction, the x component of my normal force is 0 newtons. My frictional force acts in the x direction. I measure my frictional force and determine that the length of my frictional force is 1.2 centimeters. Using my conversion factor that 150 newtons equals 1 centimeter, I obtain a value for my frictional force of 180 newtons. Because this force acts to the left, the value is negative. The horizontal component of my frictional force is negative 180 newtons. Because it only acts in the horizontal direction, the vertical component of my frictional force is 0 newtons. I can now verify that I've done everything correct by double checking my table. Let's start in the x direction. Negative 615 plus 0 plus negative 180 plus 800 equals 5 newtons. 5 newtons is a very small difference, and that is due to errors in my measurements. If the markings were more exact, I would get exactly 0 newtons. 5 newtons is not a big enough difference for me to be worried. Let's check our y components. Negative 1,335 plus 1,335 plus 0 equals 0 newtons. I feel pretty confident about my solution. Let's return to our question and make sure that we've answered all of the questions. A, determine the forces that act in the x and y direction. We did that when we completed our table. B, determine the normal force in the x and y direction. The normal force in our x direction was 0 newtons, and the normal force in our y direction was 1,335 newtons. C, determine the resultant value of the normal force. Our total normal force is 1,335 newtons. This problem is now complete. If you have any questions, re-watch the parts of the video that you found confusing. We will answer more questions and do more practice problems tomorrow in class.